I'm Dr. Ralph Ford, Chancellor of Penn State Behrend, and you are listening to Behrend Talks. I have two guests today. My guests are Dr. Darren Williams, Professor of Astronomy and Astrophysics, and Dr. Mike Rutter, Associate Professor of Statistics, and I will add astrophysics enthusiast, because we're going to be talking about the solar eclipse today. And they've both joined me to talk about the solar eclipse that will happen on April 8th. For those who have not been listening, they have not been watching the news, everyone should have heard about it by now. And it should be visible in totality if the weather holds here in Erie that day. Anyways, welcome here, guys.
Thank you.
Well, I am going to run through your backgrounds just a little bit here. Darren is known to many because you hold the very popular open house nights in astronomy here on campus, where you give talks that are attended by very many, and it's a great compliment to the engaging lectures that you have. You hold a PhD in astronomy and astrophysics from Penn State University, a bachelor's degree in physics from the University of Pittsburgh, and an associate degree in physics and mathematics from Jamestown Community College. Your research is focused on the climates of
Small planets.
small planets, and spin orbital dynamics of planets and moons, among other topics. We could probably spend a whole discussion on that one. And Mike holds a PhD in fisheries and a master's in statistics from Michigan State University, a master's in applied mathematics from the University of Tulsa, and a bachelor's in applied mathematics from the University of Pittsburgh at Bradford. Your research is centered in statistics, predictive models, and quantitative fishery models. Mike is also the Associate Director of the School of Science and co-chair of our new interdisciplinary science and business major. And we can talk about that today as well, too. Anyways, welcome to the program. We're counting down to the April 8th total solar eclipse. It is a once-in-a-lifetime event. Fill us in. Start with the basics. What's a solar eclipse? What's this mean to be in the path of totality?
Right. So the moon, 250,000 miles away, casts a long, narrow, dark shadow all the time into space. And occasionally, very rarely actually, it touches the Earth. And we just so happen to be right underneath the point that it touches on April 8th. And the event doesn't last all day. It'll be a couple hours for us in Erie from start to finish. But the middle of it is what everybody's waiting for, where the moon covers completely the solar disk. And the afternoon sky will turn dark as night for 3 minutes and 40 seconds.
3 minutes and 40 seconds. It will be 100% totality
100%.
In Erie.
Yeah.
Now, how far does that go away? So if I drove 30 miles south of here, would I be 100% totality?
The shadow for that day, it changes with different eclipses, but for that day, the shadow width is about 150 miles in diameter. And so you'd have to travel about 70 miles south of here to leave the shadow.
So they won't see it in Pittsburgh at all?
They won't.
Okay. So it gets as dark as midnight?
No. Along the horizon, you're actually receiving some light from the regions of the atmosphere outside the shadow. So it won't be pitch black like at midnight, but it'll be overhead will be the darkest, right in the middle of the eclipse. I would compare it maybe to twilight conditions. It'll be dark enough to see stars, and that's my most exciting aspect of it, because not only we'll be able to see the fluorescing atmosphere of the sun called the corona, but away from the sun, we'll see familiar constellations and the planets will all be lined up. So for the first time in my life, I'll be able to see the entire solar system arrayed before me in the middle of the afternoon.
Wow.
Yeah.
Will you have telescopes set up to
Yes.
see this?
Yeah. So we'll have a series of filtered telescopes, mainly pointing at the sun, and so we'll be looking at the sun for an hour before and an hour afterward, and you can do it safely with a filter on the outside of the telescope. But during the 3 minutes and 40 seconds, we'll be able to see stars and planets without glasses on our face and without looking through the telescopes.
And the world around us will think it's going to get dark. Street lights will come on, Animals will start to act like it's getting dark, so they might move when they normally do, and then about 4 minutes later, they'll discover that, oh, wait, the sun is coming back out. So it'll be an interesting afternoon in lots of ways.
I remember we had a partial eclipse here within the last decade, right?
2017.
2017. And I remember the crickets started chirping.
Yes.
Yeah. What other? It'll get cooler.
Yeah, 10 degrees roughly.
Drop 10 degrees. Okay.
And everyone will be gasping at the view. We're hoping that it is clear that day. In April in Erie, the forecast could range from blizzard conditions to a rainstorm to an 80-degree bright sunny day. So,
well, let's assume the worst case. Let's assume hopefully we're going to get the best weather. But even if it were bad weather,
right,
we'd still you're going to feel this. You won't see the sky as well, but you're going to definitely know something's going on.
Yeah, absolutely. I think the streetlights will come on.
It will get dark. The worst case scenario is like a storm in which it becomes dark because there's too many clouds in the sky. But even if it's just, if it's just mostly cloudy, we'll still be able to see the effects of the eclipse. We just won't be able to see the actual moon going across the sun.
So how rare is this?
It's rare. So within every year, the moon's shadow touches the Earth 1 to 3 times on average. If you ask what fraction of the planet does the shadow touch, it's less than 1/10% of the planet. Mm-hmm. So people are familiar with the moon during a lunar eclipse. Mm-hmm. That tends to be most people's eclipse experience, because when the moon gets eclipsed, half the planet can see it. So now our planet population is 8 billion, and so with an eclipsed moon, 4 billion people at any one time can see it. Here, you have to multiply the population of the Earth by 0.1%, and that's the fraction of the population. So it's a very rare event for any one person. You have to either get lucky, like we are in Erie, and wait for that shadow to come to us, or a lot of people, the eclipse enthusiasts, the travelers, they fly, they take voyages to place themselves in the eclipse.
I know some who've told me, I'm coming to Erie. I've learned what's going on in there.
It's relatively easy to get to for North Americans.
Yeah. So the next one, if I'm correct, 2144. So this is more rare than Halley's Comet.
Although the one in 2144, that's the total solar.
So the next total solar eclipse.
For Erie.
Mm-hmm. And I think Halley's Comet, I guess I'm just using as reference, every 76 years.
76, yeah. Just this past year, or a few months ago, it turned around, Halley's Comet. So it is now officially heading toward us.
It's heading back?
But it won't be here until 2061 or 2062.
Well, maybe we'll get to see it. I don't know.
The next solar eclipse actually is going to be August 12th, or that's the next total solar eclipse is going to be August 12th, 2026, but that's going to be in Iceland, Spain, and Portugal. So in terms of a worldwide audience, that's going to be the next time this is going to happen on Earth. It's just, we're not going to be able to see that.
No, I'm talking about Erie won't get it.
Right. So, but it kind of gives you an idea of how rare of an event it is, and it has more to do with where you are on the Earth rather than frequency, because that's the thing that makes it rare.
Sure.
So here comes the really hard question. How do you predict this with such accuracy that you know the next time, for example, will be Erie, Pennsylvania? For Erie, Pennsylvania is 2144. How do we know that?
Lots and lots of math.
Mm-hmm.
I mean, it actually started out as like...
You don't have to go through every bit, but give us a flavor.
No, I mean, it's actually started out as more of a statistics problem, because ancient civilizations that were really good at taking notes of things happening would start writing down when eclipses occurred. This was the Chinese and the Babylonians in the 7th, 8th century BCE, and they started noticing there was a pattern of when these eclipses would occur. So they were able to start predicting it just based upon, approximately about every 18 years, which is, Dr. Williams, is a Soros cycle, correct?
Yes.
That these eclipses would happen. So they would notice that these were occurring. Now, it doesn't guarantee it's going to occur at the same exact place, but they were able to start to figure out that these things happen on a cyclical basis. And so people started getting a good idea when it might happen, maybe not exactly where. It wasn't until the 1820s when a Prussian mathematician, Friedrich Bessel, created a set of equations that much better allowed us to predict exactly where and when eclipses would occur. And so from that point on, we've been able to predict it. And then obviously with advances in computers, we've been able to take into account things like elevation and the way the moon looks and where mountains are on the moon, so we can predict exactly where the eclipse is going to be. So it's been the last couple hundred years we've been able to predict it with a lot of accuracy.
Makes a lot of sense. If we go back to those ancient civilizations, what did they think was going on? Did they understand the physics, or did they have superstition around this? They
did.
were obviously figuring this out. So what did it mean to them?
Yeah, they said it was a sign of impending doom, plague, disease, starvation, some climate change, warfare.
Or maybe the gods were upset with a leader or something along those lines. Yes.
Yeah, because they didn't understand it. They couldn't predict it until just a few hundred years ago.
But I think the folks that
most people couldn't predict it.
Most
there
people
were a few,
right,
like Archimedes, for example.
Right, those that were scientifically inclined in those days for what science was, they would notice, hey, these things are happening on a regular basis. And I think that would be the start of, well, maybe these aren't related to angry gods. This is actually something that's occurring in nature.
Sure, they were the scientists who put their life on the line, of course.
Exactly.
By going against the modern day, the belief at that time, and they were heretics. So, but we come forward to today. Everyone's going to be celebrating. People are going to be coming to Erie, Pennsylvania. Do we have any estimates? What's going to happen? Do we know how many people are coming to Erie to see this?
If the weather is good, the estimate is going to be 250,000 people coming to the Erie County area that day.
So we would double in population.
Yes. Basically, the I-79 corridor south to Pittsburgh and then on to Washington, D.C., if you look at it from a spatial setting, Erie is the closest and easiest place to get to. So if that weather forecast is good, we are going to be the place to see it for those particular people. That's why they're estimating that
For New York City, they'll just go north up the Hudson Valley, and they'll hit the path of totality near Plattsburgh or Burlington, Vermont.
Sure.
Or even Rochester, Buffalo area is closer than us.
So all the hotels are sold out?
They're not sold out the last time I talked to Visit Erie. However, prices are incredibly high. So if you do want to book a spot, you better do it now before they get even higher.
So we're having a lot of events here on campus. Tell us what's happening on campus that day.
So at high noon, I'll be speaking in the Erie Hall Gymnasium, I think to 1,000, 1,500 visiting high schoolers from Pittsburgh. Is that the
and other areas outside of the path of totality? Yeah. We've been getting phone calls for the past year about coming up and coming here to see it. So we'll be entertaining those high school students with that talk. Yes.
Right. So that'll occupy us until 1, and then from 1 to 2. We'll all be getting ready, getting our glasses ready, and attending to the telescopes over by the soccer field next to the Junker Center. And then by 2 o'clock, the moon starts to eat away at the edge of the sun, all in preparation for the 3/18 total solar eclipse. And that's when you take your glasses off. So everybody's going to have their glasses, but they can't forget, well, they'll figure it out, because you can't see anything with your glasses on except for the sun. So during the eclipse, when it's totality, just after the last flicker of sunlight through the valleys and mountains on the edge of the moon, the last flicker, the glasses come off, and then you're safe to go for 3 minutes and 40 seconds.
Wow. Will we be announcing that people will know this, that they can do that? Because I'm sure there's a lot of misunderstanding around
we will
this
We will be describing what's going on. We'll give an announcement saying it's safe to take off your glasses. It'll be telling you when it's safe to put your glasses, or when it's important for you to put your glasses back on. And then, we'll be walking everyone through the whole.
And the meteorologists from Jet TV, both of them are scheduled to be here all afternoon. And somebody's going to have a microphone. I'm supposed to do it play-by-play while the eclipse is taking place, describing what I'm seeing. I hope I can still see maybe through the clouds, if there are clouds, or just identify what can be seen in the sky.
Well, we all know, or most people know, you need glasses during this eclipse.
Right.
Where do you get them?
Well, there's going to be a lot of places where you can get them. I think the easiest way right now to get them is to come to a planetarium show at the Yon Planetarium. There's a free set of glasses with every paid admission. There are shows every Saturday until the eclipse, and there are some weeknight shows as well.
Right.
So you should check the website to see what that schedule is. I know that local business Country Fair is going to be selling glasses or giving away glasses free with a purchase, starting I think near the about halfway through March. So that'll be a way for Erie area residents to get glasses. There will be glasses for people coming up. Visit Erie is going to be offering glasses at various rest stops getting closer to Erie. So there's going to be lots of different ways you can get a hold of them. Honestly, the best way to see that list is to go to Visit Erie, and they will have a large list of how you can get glasses for free. If you go to the Behrend Eclipse website, there are instructions on how to purchase glasses for yourself and how to get them from a reputable place and make sure they meet all the qualifications for safety. So you can find that information on our website.
So in addition to the publicly available glasses, we've actually got quite a few available here on campus, and through the support of some of our generous donors, notably Greg Yon and John and Louise Mangus, Penn State Behrend is able to purchase 50,000 pairs of eclipse glasses that are being distributed widely. So tell us a bit about that.
Yeah, so through those generous donations, we are going to be able to distribute glasses to every K through 12 student in Erie, Crawford, and Warren County for the eclipse. And thanks to actually some cooperation with Mercyhurst University and Gannon University and Penn West, we've gotten enough now that we're going to be able to do that for all the faculty and staff at those institutions as well. And if you have homeschool children or private schools, and if we have reached out to as many of those groups as we possibly can, but if you're not aware that you're going to be able to get those glasses, contact the School of Science office here at Penn State Behrend, and we'll make sure we get glasses for those groups as well.
They call you up?
Yes, they can email me. My email address is mike@psu.edu, and if you send me an email and give me some information, we'll reach back out to you, and we will make sure you get those glasses.
Perfect. That's easy. Mike@psu.edu.
I'm the only Mike that works here. That's not true.
But it is super important people have the glasses. So let's talk about the seriousness of that and when and how you wear them. I know you know well, but...
Right. Well, the nice thing is when the slow parts of the eclipse are happening, just as the moon starts taking a piece of the sun's edge, starts covering up a little bit of the sun around 2 o'clock. That's relatively slow, and so very little happens between 2 and maximum eclipse. And so that's time for, if you're short on glasses, if not everyone has one, you can take yours off, don't look at the sun, but you can take yours off and share it with the person standing next to you easily enough. And so you can share your glasses for that hour before totality. And then when the rapid things happen, when the changes go more quickly, then everybody has their glasses off anyway, and you don't need them. And you don't have to worry about you do have to worry about who has the glasses at last call, so that after the 3 minutes and 40 seconds, they go back on.
And during the time before the totality, and when you need the glasses, but it's only when I'm looking at the sun. So if I'm just walking around, I don't need to do that.
Right.
No, just like normal, you don't want to look directly at the sun. That is totally true up until totality. So when it's covered 99%, you should not be looking directly at the sun. So you need to view that either through glasses or through some indirect method.
And the consequences are
Eye damage.
Yes.
eye damage, blindness.
If you stare at it long enough, yes.
Don't take the chance.
Yeah.
Don't take the chance. And,
And if you have prescription glasses like us, you just put the others over it.
yep, that's all you need to do.
Okay.
We've been recommending that children under the age of 5 shouldn't even view the eclipse with glasses. There are many indirect methods you can look at them through, like a pinhole, cardboard box setup, or you can actually hold up a colander and you can see the little pieces of the sun will show up on the ground multiple times. You can watch the eclipse that way. But getting small children to keep the glasses on, there are other
That's
ways.
a little too risky.
Yeah, there's other ways they can do it very safely. So we highly encourage those students, or the youngest among us, to watch via indirect methods.
So when this is all happening, I'll switch back to the physics of it. How fast is the moon moving?
It's traveling around the Earth at about 2,000 miles per hour. But while it's doing that, the Earth is rotating underneath. And so Erie, we don't feel it, said my mom just a few days ago. She doesn't feel the Earth's rotation, but in Erie, the velocity is between 500 and 600 miles an hour around the center of the Earth. And so as the shadow flies overhead at 2,000, then we have this, we're trying to keep up with it with the rotation of the Earth, but we don't. And so the shadow just it comes and goes, and it spends 3 minutes and 40 seconds in the Erie region before leaving. It takes about an hour and a half to 2 once it touches the planet, which happens somewhere just south of Mexico. It goes through Mexico and then into Texas and then through North America, up through Indianapolis and Cleveland, through Erie, Buffalo, Rochester, and so on. And that whole time scale is less than 2 hours, usually about an hour and a half from start where it touches the planet to when it leaves the planet.
Wow. So by the way, someone recently asked me, I don't know why, if I knew the circumference of the Earth, and I knew it, and they were surprised. Why would somebody know such a number? It's like 25,000 miles, right, at the center. Yeah. So it's a pretty easy calculation that it takes 24 hours. So the Earth at the center is about 1,000 miles per hour. So it makes kind of sense. It's 500 or 600 miles here in Erie.
Right.
Makes
a
all
congratulations. I'm glad
well, you... I thought it was like a pretty common knowledge, actually, for people to know that. I thought we all learned that in grade school.
We did, but a lot of people forgot.
Yeah, a lot of people forget. Anyways, I'm not bragging, but I just found that was an interesting conversation. So it's easy to figure out how fast the Earth is moving. Anyways, let's talk a little bit, though, about travel. It's a mixed message. If you're living in Erie, you're telling people to stay home, yet we want people to visit campus and enjoy the festivities. So what do you recommend people do on this day?
I've been a big proponent of, if you live in Erie County, the best way to watch the eclipse is from your own backyard, mainly because you will have food and you'll have plenty of access to bathrooms. No reason to leave the comfort of your own home to watch it. There are going to be various places in Erie County that are going to be having events. Some of the wineries along the lakeshore are going to have events and things like that, but you can see the eclipse from everywhere. As long as you can look out southwest direction about 45 degrees above the horizon, you should be able to see the eclipse. There's no reason to brave the crowds to go watch it, so you can get a great experience at home.
Good plan. A lot of places are closing down. County government. We're not having classes here on campus
Most school districts in the Tri-County area are not having remote classes that day as well. So there's going to be a lot of people staying at home waiting for this to occur.
It's a great idea. And if they come to campus here, where do you recommend they go to view? You said the
soccer field is where our telescopes will be, but not everyone wants to cram into the soccer field. So if they're trying to get to campus, either for our talk or for a bathroom or to possibly see through the telescopes in the soccer field, Station Road, Knowledge Parkway, along the edges of the road would be the best. Staying close to I-90 or close to the Erie Bayfront. So you have to have plan A, B, and C ready to go that day. If I-90 is closed, then the Bayfront may be the next best thing. 38th Street through Erie might be the next best thing. For a good forecast and for sunny skies, it's going to be crowded that day.
Well, all good advice. Maybe get there early and get your spot too, right? And be patient with traffic.
The closer you are to the lake, slightly longer totality will be. Mm-hmm. So, Meadville's about where it starts, and that's only about 1 minute and 20 seconds. And then as you get closer and closer to the lake, the longer totality will be.
Mm-hmm. So, Astronomy Open House, will you be having some between here and the eclipse and focusing on the eclipse? When can people learn more?
There are a bunch of talks about the eclipse and programs in the On Planetarium. But March 20th, which I think is a Tuesday, there's a public talk at the Blasco Library downtown in Erie. And then...
You're giving the talk?
I'm giving the talk. Oh. Jim Gabbio's tag teaming. He's the planetarium director, and he'll be there as well. And then April 3rd is the Astronomy Open House here about the eclipse. It's essentially the same talk about the history and the science of eclipses. But then that talk at noon on April 8th, and that'll be a similar talk yet, but maybe there will be a sense of enthusiasm for the upcoming, what we're going to see in the afternoon.
Well, for our listeners, I can say from firsthand experience, you are a great lecturer. People should go and hear what you have to say. They will be enthralled.
Great.
I want to talk about a few other things, but before we do, is there anything else we're missing about the eclipse or that you would like people to know about that day?
We already mentioned that we can look at the sun safely through our glasses, And then during the 3 minutes and 40 seconds, we can take off our glasses and stare at the sky and look for stars and stuff like that. But the other thing that happens during an eclipse, when a lot of the sun, maybe 85% of it gets covered. So this will happen around 3 p.m. that day. If you just look down on the ground, you'll see strange images of the sun cast through the leaves, through holes in the leaves. And I don't know how many leaves we'll have in April, but also holes in buildings, anything that can act like a little pinhole. These images of the eclipsed sun will start to become more distinct, more well-defined. Now, these images are always made right now in the middle of the afternoon. It's a bright sunny day out there. There are images also being formed, but we don't see them primarily because there's light coming not only from the sun, but light coming from everywhere, from the buildings, everything scattering off the snow and the sky. But during an eclipse, all of the light, most of the light now is concentrated, coming from one direction, and that's where the sunlight is.
So the pinhole works.
And the pinhole, and those images become very distinct and noticeable, and people think they're losing their mind, but that is, there are thousands or millions of pinhole images cast on the ground during an eclipse. And you should be able to see those probably within a half hour, 20 minutes of totality.
Would it help to walk around with a small piece of cardboard and with a pinhole in there?
Sure.
Absolutely, I think. Sounds like a good idea to have your own that day there as well. So, well, let's talk a little bit about what you both do in your day jobs, which is you're faculty members here. You teach two different subjects. But let's start with you first, Darren.
Yep.
Talk about astronomy and the courses you teach and what your passion is.
Right. So I'm an astronomer, and I teach every semester. I teach large astronomy classes. It's a very popular topic, and so every semester students ask me, "When is your next astronomy class?" I say, "Well, it's next semester," because I always teach one of those. And my professional mission is to understand things to the point where I can explain anything simple enough so that anybody can understand it. I always use my mother as an example. If I can't explain it to my mom, what good is it? So I find ways, both in my mind, but also on using computer programs and research. I investigate the physics of how planets move and how satellites move around the planets and how they were formed. And then it is very complicated. I'm not going to lie, but it can be understood and explained simply. And the eclipse stuff that I'll be talking about endlessly for the next 49 days until eclipse day, it is, if you dig into it, you'll find a complexity which is beyond most of us, including myself. But there are some simple things, some simple takeaway points, and I'm going to attempt to explain that to as many people as possible.
Good for you. Did you know you wanted to study astronomy when you were a young kid, or was this something that you grew into? You knew?
Yes, primarily after watching Cosmos and Carl Sagan on TV. I said, I want to do that. But I didn't know what that was. I just knew it looked cool, and I wanted to know what he knew and be able to explain how he did. And so he was really my inspiration.
And that's all you need is the spark, because these things take lifetimes to develop expertise, and that's what people need. Young kids need to understand that. How about you, Mike? Statistics, math. What do you do in your day job?
I teach statistics at a variety of levels. I teach introductory statistics to any general major, to biologists in a biostatistics class. I teach upper level statistics courses, and I teach a course in statistics for our clinical psychology graduate program here at Behrend. So I cover lots of different bases with that.
So widely applicable, and as they say, liars use statistics. And what is the statement? But we hear so many
lies, damn lies, and statistics. Yes,
that's it.
Something along those lines. Yeah, I mean, it's interesting. I loved physics when I was in high school, and as I said, I went to school. I was going to be I wanted to be an astrophysicist, and I ran out of math classes to take, and so I took a course in mathematical modeling and biology, and I learned that the thing I liked about physics was that I could model how stuff happened with math. And then I learned it wasn't just related to physics. I could do it in biology. And I went, wait, that's even more exciting to me. So I kind of knew that was going to be my direction. So learning how to model things and using data to tell stories, and that kind of got me to where I am today, and why somewhere along the line I changed majors from math to fisheries, because I wanted to tell stories about fish with data. And so that was a good path for me.
So why should somebody study statistics?
I think because, especially as in these days, we are surrounded with numbers and data, and to be able to figure out what is important and what is not so important, and being able to make good decisions based on the data that you have, I think is a really important skill that can be applicable to lots of different fields.
Yeah, I think it's so important to understand it and have a base understanding, because if you think things are all deterministic and easy to follow, it really gives you a way of thinking about the world too that I think helps you understand the complexity of the world.
And one of the main things about statistics is being able to deal with uncertainty. And so being able to quantify uncertainty and being able to how to handle it as another important part of statistics, I think, is really important.
Well, you are also the chair or co-chair of a relatively new academic program here on campus known as Interdisciplinary Science and Business. Can you talk about what that is?
Sure. So the ISB was what we call it for short. What we're doing is we are training students to work on the business side of a scientific company. It is a joint program with the School of Science and the Black School of Business. For example, we might train someone to help coordinate and run the chemistry labs of a chemical company, or maybe they're doing technical sales for a pharmaceutical company. We want to combine that science and business techniques and skills. And so the way the degree program works is we have a set of courses, core courses in both science and business, and then the students need to take a specialty in both. So in science, it's either lab sciences, human health, or quantitative sciences, and then they couple that with something in business from finance, supply chain, or technical sales. And so you combine one of each from both science and business, and that's your kind of customize your degree and really focus on what they're interested in doing and how they might want to apply that to a scientific company.
Sounds like a great program. Anyone who really wants to understand science, but make sure that they can go out there into the business world, sounds like a great fit.
Yes, it is, and it's modeled very closely after a very successful interdisciplinary business with engineering program, a very similar structure, and we hope it is as successful as that program has been.
Well, gentlemen, it's been a real pleasure today. I have really enjoyed this discussion, and we are all waiting. You know, April 8th is not all that far away before we know it'll be here and gone, so people should not miss it. This is a once-in-a-lifetime opportunity. Appreciate your expertise today. My guests have been Dr. Darren Williams and Dr. Mike Rutter. Gentlemen, thank you. You have been listening to Behrend Talks. I am Chancellor Ralph Ford.